Well, welcome everyone. Welcome to the EOcafe, where the EO community meet. For those of you who haven't joined before, the EOcafe is just a very informal discussion. We join with our cups of coffee, our cups of tea, hope you've all got one, and talk with some guests and some special guests that we bring along to talk. This is the third EOcafe of 2021 of this year. And this time we're looking at the raw materials sector and how EO can help serve the raw materials sector, and indeed what are the issues that need to be addressed, the challenges and solutions for EO for the raw materials sector. I'll say a little bit more in a moment, but firstly we have three special guests. Margriet van Malen from Deltares, Reinier Oost from Sensar, both in the Netherlands, and then Brendan Morris from LTMS over in Ireland to the west. Maybe we could just start, if you could just say a few words just to introduce yourselves and the organizations, and then I'll come back and introduce the EOcafe afterwards. So Margriet.
Yeah, thank you, Jeff. Well, my name is Margriet van Malen. I'm working at Deltares, which is a not-for-profit research institute in the Netherlands. Within Deltares, we led the project we're discussing today, Earth Observation for Raw Materials. And in my other time, I work on wildfires and also climate resilience questions.
Right, Reinier.
My name is Reinier Oost. I'm from Sensar. My role at Sensar is product lead, bridge the gap between the developers, the space nerds on one side and the commercial activities on the other side. At Sensar, we specialized in measuring surface deformation from space.
Okay, thanks. Brendan?
Good afternoon. My name is Brendan Morris of LTMS, Lachine Technical and Mining Services. We're a small mining consultancy and training services provider based in Ireland. I've been in the global mining industry for more than 40 years now. For this project, we've been asked to bring the mining insight to complement the project management of Deltares and the EO capabilities of Sensar and Geoville. We have to say we started with a limited knowledge of EO technology for this project, but quickly learned the extent of the possibilities that are in the EO technology for the mining industry. So happy to have been engaged in the project.
Oh, that's great to hear, and we're obviously here to help learn more as well. Just a quick reminder of the rules. Keep microphones off unless you're speaking. So stay on mute. Feel free to use your camera. Adds to the ambience of the cafe. If we can see each other. And we'll ask questions. Be time for questions later, but please, if you could put your questions in the chat, and then when it comes to it, I will ask you to take the floor to ask your question. But we'd like to have them first in the chat so that we can combine them or order them in terms of the conversation. So this cafe is about raw materials, EO and raw materials. About 10 years ago, we started building a community with the oil and gas sector, which was called OGO. Just over 10 years ago, there was a conference in Ezrin, organized by ESA, of course. And that led to an informal grouping around the oil and gas industry, experts from the oil and gas industry and experts from the EO sector. That led into a study, a fairly deep study into the sector needs, which were published, and that was really appreciated by the oil and gas sector, and that led on to ESA introducing these best practice studies. So the first one on agro-insurance, where we had an EOcafe on that subject last November, and then today's project looking at the raw materials sector. And personally, I think they're an excellent approach to understand what are the challenges, what are the services, and to start to break down some of the barriers between the sectors and to the take up. So today we're going to be looking at raw materials, looking at the challenges, the products and services that can meet those challenges, the gaps, so where there are products and services that could be used, and of course the barriers to the take up. And the last one particularly, I guess we will come on to in the discussion. So how is EO used in the sector today? What are the challenges and trends, and what are the barriers? So without further ado, let me pass the floor to Margriet, who is going to introduce what the team have been studying, and then we'll move on from there. Margriet.
Thanks, Jeff. I just received a message that my internet connection is not that stable, so I hope it holds on for another moment or half an hour.
For the moment,
I'll
it's
share
okay.
my screen first. Yeah, thanks. I hope you can see my screen now.
Yeah.
Thanks. Well, thanks, Jeff, for already introducing three of us. There was another party next to Delta Aris, LTMS, and SNT, and that's EOcafe. And the four parties together, we performed over the past year and a half a project on Earth observation for the mining of raw materials. I will briefly go through the main deliverables of this project and really to get the discussion started. So the goal was, and the title is, unlock the potential of EO for mining. To do so, we started in the middle of this figure with the gap analysis, because we really wanted to know what are the current needs for the raw material sector, and what is the current status of EO technology, and how can those be matched. Out of that, we also developed two mock-ups, which will be demonstrated later on by Reinier. And finally, we looked at how can we best implement this. So how can these type of products be scaled up? And this resulted also in a roadmap and an implementation report. So we are four parties and we performed the project. However, we had an international advisory board, and those are in the circle next around it. And I saw some of the people from the advisory board also attending the meeting, so that's nice to see. Thank you for that. And also on a wider scale, we had support from ESA, of course, but also from ERSC, which invited us for this meeting today, by the European Commission, Geosurveys, and Euromines. And all together with these groups, we hosted as well two workshops, one in real life and one online via webinars, to gather feedback and really to get their input and validation. So the first part of this project was a gap analysis. And to do that, we identified all the geoinformation needs that were available. Brandon will go into more detail later on about it. And we also looked at the availability in the EO data sets. And we then looked at, so what are the biggest gaps? For example, these geoinformation needs, those are all available on the ERSC website. And if you go there, you can see all the challenges and then see per part of the mining cycle, the challenges. And if you click on that, you can see a small description and the linked EO products that are available. And we also looked at the availability of the EO potential. This is a very intense picture, but it shows you how many product sheets there are. I will look at two of them for now. For example, groundwater monitoring, where you have per product a nice product sheet with a picture and also describing, for example, the spatial and temporal resolutions. The other one is ground stability, which also will be described later on by Reinier. To find this gap analysis or to really find where the gaps are, we scored all products on how are they utilized, what is the demand by the mining industry, and what is the capability, the current capability. And then you can see that there's some EO products that are available, are already there and are at very good resolution. So for example, if the mining sector is looking for products which needs a certain temporal and spatial resolution, and it is already being used. It's only a guideline candidate, so that's all the way up in the top right. So that means that the Earth observation product is already quite developed and it's already being used. Then there's a group of sets of Earth observation products that already have quite a lot of capabilities, but are relatively underused. And then in the right bottom corner, there's a high need, but it's not available yet by Earth observation. And those were identified as products with an R&D gap. So we plotted those as well in very nice pictures. And based on that, we identified at least two products, so stockpile monitoring and ground stability monitoring for a surface mockup, which is shown here and will be demonstrated later by Reinier. And based on with that, we went back again to our advisory board and we hosted 2 webinars, and we tried to see what are the current barriers to fully unlock this EO potential. And in general, what we see is that there are many EO products that already have a very high quality and already fit to the needs of the mining companies. However, it's blocked. Well, nowadays because of unawareness, for example, but also because of the costs maybe, or maybe the skilled people are not there, and maybe there's more communication needed. And those are all types of barriers that are there. Several ways of overcoming are there. So, for example, you could think about hiring more people to really be able to translate these EO products to the needs by the raw material sector, or get more open access to the EO data services. And for now, I would like to keep it like that. And I will give the screen back to you.
Thanks, Margrethe. So, Reinier, I think you will come in and give us some examples, concrete examples.
Yes,
Still with us,
thanks.
yeah.
Yeah, hope everyone can see my screen. So let me first describe what you see. You see colors. The colors indicate ground stability. It shows the deformation of the surface. This is all measured by satellites. These satellites orbit the Earth at 800 kilometers altitude. They revisit every site every 6 days. And they can measure up to millimeter precision how the surface is deforming. You see the green colors, which indicates stability. You can see red colors, which indicates subsidence. You can also see blue colors, which indicate uplift. You don't see it that often, but it can happen. The color indicates the linear behavior of the ground, but there's a time series behind it. I brought 2 very nice cases to the floor to showcase the potential that's in this kind of Earth observation data. This is a scorpion zinc mine in Namibia, and there has been a slope collapse in this region over here. As you can see, it already correlates with the colors. You see there is a red spot right on top of this slope collapse. And when we zoom in more into the location, you can also see that there is data on the location that indicates an acceleration of subsidence. So the ground started to deform more all the way up to May 2019, when there was a collapse. This is not only visible when you look at the collapse of the slope, but even outside. You see the colors are gradually getting more and more orange, but also in this location, you see that there was a relatively low subsidence that started to increase all the way up to May 2019. This is about slope stability. We did a similar case for the Gadia gold mine in Australia, but now for a tailing dam. So again, the colors indicate stability and movement. And there has been a big collapse over here, caused a lot of damage. Of course, when all the mud waters are being released, there's a lot of environmental damage. And also on this spot, there's a very clear single precursor at the start of the collapse. The collapse is in March 2018. And you see that in 2016 and 2017, all the way up to November 2017, there is stability. There's a flat line, which suddenly starts to move. And this has been the precursor for the deformation at this spot. With this insight, with this remote monitoring, you can try to detect these kind of events and step into them before they happen. And again, this is all done by satellites, no human interference required. This is all done remotely, and it can be done very frequently. Then I give the screen back to you, Geoff.
Okay, I think it's Marguerite that needs to take it back for Brendan, just to explain a bit from a broader perspective.
Brendan, you're still muted.
Sorry about that. So from the mining perspective, just to touch back on one of the previous slides, we can see that mining was broken down into 4 sectors on the mining cycle: exploration, planning and development, operations, and closure and aftercare. And these are just some examples of the EO-technology that's being used or is capable of being used in these areas. In exploration, you've got geographic and geological modeling or mapping, planning and development, water catchment, flora, fauna, population. In operations, ground stability, water monitoring, and ground stability has been used quite a bit. In the subsidence measurement using EO technology was used in a significant legal case at the Lachine mine in Ireland in 2015 during my time at the mine. And it provided factual information on the levels of subsidence from before the mine started, throughout the life of mine, and to the time following closure. And it actually, it was the key part of the evidence used in the case. And that was quite a public case at the time. So it was very effective in its use. In the closure and aftercare area, it can be used for rehabilitation, revegetation. In the project itself, whilst we identified many different areas of use and potential use, we did highlight 3 main areas. We highlighted tailings dam monitoring, which we've touched on earlier. And that technology is already in place, but probably not that readily used. In some cases it is, but in other cases it's not. Pit slope stability, the technology is already in place, but again, probably not widely used, or not widely used enough. And the third area then was stockpile measurement, and we did some good studies on stockpile measurement, but we found that the technology isn't quite there yet, and it's an area that will need a bit more research, and then certainly an area of challenge for EO technology providers. So they were some of the interesting findings. Next slide, please, Margate. So in terms of tailings dam stability, and Rainier touched on this a little while ago, but it's important to know that there are approximately 3,500 tailings dams worldwide. And a recent study shows that suggests that there are 2 to 3 failures per annum, affecting an estimated 1.3 million people, putting them at risk. So there have been some significant dam failures recently, with multiple fatalities, notably in Brazil. So what can this technology do? Well, it can certainly highlight required preventative actions, and it can provide early warning of imminent failure. So that's really important for the mining industry. And if you think of 3,500 tailings dams and the amount of work that it would take to actually monitor them on a regular basis, when you can simply use EO technology, I mean, it's a huge step forward, particularly in times like this when we don't have access to travel as we used to. As Rainier showed earlier, the Cadia Dam was a very good example of that. So next slide, please, Margaret. The second area, again, was pit slope stability, and this is an area that is a major safety and production risk for the industry. Pit slopes require continuous monitoring, and it's currently carried out with traditional survey techniques and drones, etc. And there's been a number of high-profile failures in recent years, and the most notably the Bingham Canyon failure in 2013, which you can see from the failure, and unless you can get kind of you can perceive the depth of that pit. That pit is several hundred meters deep, so you can imagine the volumes that are involved in that landslide. Again, EO technology can highlight the need for preventive actions. It can provide early warning of imminent failure, and it can provide a very good alternative to the current monitoring techniques that are in place. Next slide, please. In terms of pit slope stability, Rainer touched on the Scorpion mine in Namibia, which we have been involved in LTMS. There was a slope failure in 2019, and because we were engaged with Vedanta, we were asked to carry out the failure investigation on the pit slope failure. You can see it in the red area in the photograph down in the bottom left corner. And you can see the graph on the right hand side, and you can see the acceleration in the rate of change of the graph. It shows the rate of movement, which retrospectively provided a solid indication of imminent failure. The geotechnical assessment that we carried out showed that this area could have benefited from dewatering, and this may have prevented the failure. So the area was loaded with water, and a drainage program could have made all the difference. In hindsight, that's very easy and good to say, but at the site itself, they didn't have the technology in place. While they were doing some survey monitoring of the pit, they didn't have it in sufficient levels to be able to predict this failure. So there's definitely room for improvement in this type of technology, using this type of technology in mines like this. So in summary, our findings are EO is being used in some areas of the mining industry. It has significant potential to increase its use by mining companies, regulators, governments, and consultants. Mining companies include exploration companies; they're a big part of it. There are some major benefits in some areas, particularly in areas like remote access, semi-continuous monitoring. But there's a disconnect between the suppliers and the mining industry. Certainly, we found in this study there was, and my own perception of it from being in the industry and out consulting, is that there is a gap. Some of the big companies have very good programs in place, whilst some of the small and the medium and smaller companies often have no knowledge or no access to this sort of data. This can be fixed. It can be fixed by good marketing, good education programs, but we need to do that, and we need to bridge the gap. So the future is open for good connectivity between EO and mining. And I'll hand you back to Jeff now. Thank you.
Thanks, Brendan. So, I mean, the disconnect you're talking about is awareness, or one of the things that was striking me as Rainer was talking was we see pictures with the green and red movement on the ground, but then you need to look at the time sequence to understand where there's a problem likely to occur. So there's an expertise around that. Is that expertise with the supplier like Sensar, or is that expertise that needs to be built within the mining companies?
I think it's a bit of both, Jeff. I think you'll find in some of the larger mining companies, they have departmental, they have sectors built within them, populated with people who have significant IT knowledge and significant GIS capability. Those companies can easily link in with the EO providers and take care of that. However, there are many other companies who don't have that capability, don't have the budget, and mostly don't have the knowledge that it's there. And it's not only the mining companies. If you think of the tailings dams and the number of tailings dams that we have globally, 3,500. If you take Europe, for instance, I don't know how many tailings dams are in Europe, but there's possibly 500, 600, 700 maybe. if Europe was one jurisdiction and Europe decided to take care of all of its tailings dams, well, you could put a lot of surveyors out there, you could fly a lot of drones around, or you could put in place an EO technology program which actually monitors all of the tailings dams on a continuous basis, or prioritizes them on the ones that are maybe more likely to fail than others. And that's the level of improvement that can happen. And that can take away an awful lot of the hard labor and the work and the time, and give the predictability that isn't there at the moment.
Yeah. Okay. Maybe come back to that if we have time. But Rainer, in terms of the interpretation of the images, are you doing a manual interpretation, or is there an automatic interpretation there? That what are you then sending to the mining companies, or what would you send?
That's a good question, Geoff. I think the whole production flow of this kind of data is automated. We can do this anywhere in the world, and we can do it in the same way. The difference is that the type of user requires a different type of data. So most of the manual part is understanding the problem of a customer, understanding the use case, and sometimes providing maps or providing data is not the solution, but you have to think beyond this and provide insights. Yeah. We just looked at these time series. Of course, in hindsight, it's easy to look at the site and say, oh, it collapsed, and we could have seen it coming. I'd like to be challenged the other way around. Look at the site, nothing happened yet, but noting an area that has a high risk of having potential failures. I think if when you step away from the maps and go into insights, that would already be a very interesting way of dealing with the gap.
Mm-hmm, mm-hmm. And what's the timing like, Brendan? I mean, you showed you showed a collapse that was over a period of about 3 months. To pick that up, to be able to put in place. I mean, clearly there's a safety application, of preventing a collapse, whether it's a tailings dam or a pit slope, of causing danger to workers or danger to people living in the area. But in terms of remedial measures for the mining companies, you talked about dewatering. What sort of timing is needed? You're still on mute.
In terms of timing, I think every case is different, and every, let's say, a pit slope stability or a tailings dam stability, every situation is different. It becomes a geotechnical issue mostly for pit slope failures. There will be an initial amount of knowledge available on the site as to which slopes are more likely to fail than others, or which dams are more likely to fail. Perhaps not so much in the dams, but certainly in the pit slopes. And the monitoring can see movement over a long period of time. When you get up closer and you start to see a rate of change that's concerning, then you need to actually start really. You're probably getting to a point where it's nearly too late to do anything. But at least you can make people safe and make equipment safe and make the process safe. Background knowledge is hugely important. Geotechnical knowledge, geology knowledge, hydrogeological knowledge, all of that's really important in the prevention of. But understanding what the what you're dealing with in the first instance, having a knowledge of the rock type and the pit slopes. It all comes back to kind of designing an open pit. Nowadays, designing an open pit is a very intricate science, but it's not foolproof, and that's why monitoring takes place and things happen. We can only drill so many holes into the ground to understand it, but we don't understand everything that's happening all of the time. So the more knowledge you have in advance, the better you can take care of it. But when the change starts to happen rapidly, then it's too late. Then it's only time to make it safe.
There's a couple of questions around that topic, which maybe we come to. I want to just go a little bit to the barriers and the sort of what hinders the uptake. You talked I think it was Margriet talked about the the lack of skills, or the lack of, not skills, that's the wrong word, but the lack of knowledge. It applies to skills as well in the sector. And I mean, I talked earlier about the oil and gas sector, and it's very clear there that there's a need for internal skills and expertise in order to be able to procure services from outside, to know what you're talking about, to know what to buy. How much of that is a barrier in this sector? Or the big companies maybe have people, the smaller companies don't, as Brendan was saying.
Yeah, this is actually a topic we have discussed as well quite a bit. And well, I think it's in both ways. I mean, if you have a very good Earth observation company, but it doesn't understand the problems in mining, then they can deliver a product, but it doesn't fit the needs. But if you don't have any skills at the mining site and you procure satellite data, but you don't know what you're asking for, that's also super difficult to do. So, and at the same time, you also need some sort of validation, because it's a remote observation. So you need to know what you're seeing. So actually, I think both sectors would need, by having a mutual understanding of each other, but also maybe people that are able to translate that. Geotechnical experts that are more capable of using EO data, but also EO experts that understand more of the geotechnical processes.
Okay. And I mean, that question of expertise, I mean, one of the things that we've come across a lot recently in some of the work we've been doing is expertise obviously resides in one person or one or two people. But for the technology to be used within the industry, it requires a lot more than that. I've talked about institutionalizing the knowledge and the awareness of what can be done. It can also be about embedding that knowledge in the organization. Is this something you've come across in the study?
Yeah, a bit, but I think Brendan would like to respond on that as well.
Yeah, I think definitely there's different levels of institutionalization for sure. The bigger companies have it. There's no question about it. Some of the medium companies do to some degree, some don't, and some companies in the mining sector have no knowledge, so therefore no institutionalization. If you go outside of the mining industry directly and you talk about regulators and government agencies, there's definitely a gap between some ends of the spectrum to others. I'm aware of certainly some cases where in the same country there are some agencies within the government that openly embrace EO technology, whereas other sectors within the same government don't openly embrace that technology. But so that's a matter of maybe culture within the organization, or and it changes. But I think I think it's changing, and I think at some stage, at some level, most government agencies across the globe, and I'm talking about globally here. I'm talking about places like Canada and the States and South Africa and Europe. You can see the differences, and you can see where some institutes just grasp it, and they actually build the basis for that within the people they hire. And it's all about people, and it's all about people wanting to know more about this technology and to be able to use it in the appropriate areas at the appropriate times to get the appropriate results, and not use it all the time, because sometimes you still need to go out to the field and you still need to actually kick the tires, so to speak. So yeah, there's a fine balance between between getting too much, becoming too much of a what we call a desktop miner and a real miner, if you know what I mean. So there's a balance to be had there, but that's definitely the scope for advancement in the area.
Okay. There's some questions. I'm struggling to keep up with the questions, I'm afraid, but I'm going to give the first question to Arjen Venmans, which is, and it relates also to a question that Robert Heeson has asked. But Arjen, please, if you could, do you want to come in? Arjen, yeah, I see you.
That was quite some time ago. My question was, I've seen some examples now, thank you for that. And they were related to defamation. Have you also been looking into other types of permits, like soil moisture content, because that often plays a role in slope stability problems?
Yeah, that seemed particularly relevant given what was said, the measurement of moisture. And any comment, observation?
Yeah, I agree, Arjan. That's a very important topic and also an important product. And we also identified this product as a relevant product that could be useful for EO, for mining, sorry. Here within this project, we really looked at one product. So we tried to use this surface deformation and see if we can identify and fill the gap for the need. However, I think a combination of both will be better. In, for example, an early warning system, you can have a combination of the two of them, especially because what Brendan explained about the instability of this pit failure.
So Robert Heeson is asking about security applications and the importance of that for the miners. Robert, where are you?
Yes, here I am. Yeah, yeah. Because I've made the experience that actually talking to a lot of mining companies that those security-related applications are less interesting to them compared to more applications that look into exploration or into operations. And I would like to ask Brendan, what is your opinion on this?
You're muted, Brendan.
I'm not quite sure I get the question, Robert. Could you just ask the question just once again?
Yeah, well, we've approached in the past some mining companies, for example, on tailing dam security or stability, and other applications on security related applications, right? But they were like not very interested, or at least not investing money into this a lot. But they were more interested into figuring out how EO data could help them in exploring new mining sites, for example. Is that something you would copy or not?
I haven't come across the security issue at all, because that's just not the end of the business that I'm really familiar with. I can say though that when you bring the topic of EO technology up and you talk to mining companies about what the benefits are, then they start to listen. And when you talk about the benefits to a mining company in terms of dollars, that's when they really, really listen. So if security is brought to them as a benefit, and it's brought to them in terms of a spreadsheet showing that they can save X number of dollars, and they can get the value can match the expenditure, then for sure they listen, because that's how you get senior management team and mine owners to actually listen to you, to put it down in terms of value. And that's what it's about. It's a big money business, and all of this costs money, and that's the one of the top priorities, obviously, besides mining in a socially and economically and environmentally responsible manner. The cost of mining is a huge part of it. So that's where it comes back down to.
I guess security is a cost rather than a benefit.
Yes, in a
which
way.
Which is a little bit the question. I mean, Bruno Biagini is talking about regulation and the impact of regulation. Do you want to come in, Bruno, and say something around that, or still on mute? Yeah.
Yeah. Okay, can you hear me?
Yep.
Now the issue is very easy. We engaged different mining companies in some countries, and if we have regulation, there is not so much sensibility. They recognize what are the benefits, but because there are additional money to spend on safety, I'm sorry to say that very often we had no feedback because there is no indication on the regulation in the nation that is taking care for safety for additional monitoring approaches. So if to save money, they don't have to spend money in using, for instance, for tailing dam monitoring, that we know how much how critical is the tailing dam stability. So, according to my experience, since many years, unfortunately, I had the opportunity to. I faced it with this problem many times.
Okay. Please.
Safety is talk to any of the major mining companies. Safety is a top issue. There's always been this debate about productivity in mining, production being number one, and that was the case many years ago, but not now. Safety is the it's safe production is the key. However, safety goes outside a little, in some cases when you're talking about the potential for long way downstream safety issues, and that comes up at a corporate level.
Yeah.
And I think if you're hearing negativity on that, I think maybe it's not. Maybe the dialogue or the debate hasn't been fully developed.
Well, there have been a number of high-profile, quite serious accidents, which I guess help to focus minds. But it also links to what Tatiana Suarez is asking. So, Tatiana, maybe you want to come in, but around other stakeholders to the sector. So not just the mining companies, but others with a stakeholder, for instance, insurers.
Hi, yes, I attended a talk a few months ago where I think it was one of the pensions investors in the UK who were concerned about one of the accidents that happened in Brazil. So they were, maybe the pressure will come from that type of investor so that the regulation applies to the mining industry. And also my background is on energy commodities. And I started Flight from Insights in 2018, 19. And one of the first products that I was developing in my mind was around coal storage and production from Earth observation. And I did an ESA application, but I didn't get it. And now I'm focusing on a separate product, but it's still in the back of my mind, the coal storage. And
good luck with that. Brendan, you mentioned stockpiling. I presume that was,
that's right,
I was going to ask you, you're talking about stockpiling at the mines or in ports in a more general sense, or?
Well, we tested the technology in terms of stockpiling, because stockpiling is a huge issue in mining in terms of either open pit mines or underground mines. They generally have a lot of materials stocked on surface, and it's very valuable. You can imagine 100 tons with 5 or 10% zinc. Is millions and millions of dollars. So on a regular basis, either monthly or quarterly, that all needs to be surveyed. Traditionally, old survey methods were used. There's 2 surveyors out there with the equipment, and now it's more drone technology. But that's not without its problems either. Drone technology is great, but not without its problems. We were looking for the possibility that it could be that the stockpiles could be surveyed to an accuracy level that would be acceptable using EO technology, and we didn't quite get there. We didn't quite get to that level of accuracy, and I think I can't speak on the detail of the technology, but it's to do with the way the algorithms are set up and the detailing of the stockpiles itself. But it's certainly something that can be worked on going forward, so that at the end of every month or whatever given time the satellite flies over, it can pick up the stockpiles, and it can measure the changes, or it can measure the stockpile with relation to the known surface underneath it. and give an accurate volume of the stockpile, and that can be very, very useful in mining. And it can be useful in not just mining, but other commodities associated with it, and potentially other associated ideas, kind of, that anything that stores great volumes of material.
There's quite a lot of that again in the oil and gas sector to monitor what the oil reserves are. Coming to the end of the of this part of the meeting, but what I really wanted to try and consider and ask your opinion on is, what can we do more? You know, it's an Earth observation sector. ERSC is looking after the Earth observation companies, service companies, always looking to expand into new markets. With the oil and gas sector, we set up sort of informal grouping to exchange information on a semi-regular basis. That worked because there was a trade association for the oil and gas sector. Would something like that work here? What do you think are the next steps that should be taken to try to improve the use of Earth observation, improve awareness, as Brendan has talked about, in the raw materials sector? Anyone who wants to respond?
If you're looking for our team to respond, I can respond, and I can certainly say that the technology, the EO technology is run by, as Rainer well said yesterday, it's run by scientists. The mining industry is run by people who have more of a hands-on application, geologists, mining engineers, and it's not like a production line, not like a widget factory. It's really hands-on. So you have a big gap between the two kind of different types of individuals. We have to find a way so that the EO providers fully understand the requirements that the mining people have. And mining people, I mean exploration people, mining people, regulators, government agencies. So they have to find out exactly what they need and what they want and when they want it, to what levels of accuracy, and then develop a proper marketing program to be able to sell that product to the people, to explain it to them first and then sell it to them. So there's no point in having a car dealership and somebody down the road who wants it, who doesn't even know he wants a car, but you know, the car dealer is going to have to sell the car to the person who wants the car. I mean, you've got to express the need, and you've got to understand what the need is.
Yeah,
I think
if I can add to that,
Margriet,
if I can add to that, is that also what would be needed is that we can, if there's, for example, a product available or a data service available, that it would be easier to be accessed by the mining industry as well. So maybe services come in place and really tailored towards the problems in the mining, and at some point maybe with conventional methods and then new technologies combined. And that way it will become easier also for people not working on the Earth observation side, remote sensing side, but people working with the data to be able to use it and come to a next level as well.
Yeah, I think the comment about scientists, I think a lot would contend was the case maybe 10, 15 years ago, but is much less the case now. Sean, you wanted to comment.
Thanks very much, Jeff. Yes, Sean Finlay, Geoscience Ireland here. I tend to differ somewhat from my colleague Brendan Morris in relation to this, because I don't see that there is any conflict between, or that there should be any conflict between the mining companies, the regulators, the insurance companies, or the investors in relation to tailings dam safety. It's a very important and serious potential problem. And the United Nations Environment Programme and the International Council of Mining and Metallurgical Companies have agreed protocols on how to deal with this issue. And in fact, the issue is somewhat worse than outlined by Brendan. In fact, in the data that he referred to, the 3,500 tailings dams, that's true, but the data we have in terms of risk analysis doesn't include any in Russia. and I'm sure there are some problematic sites in Russia. So what I would suggest is what's needed here is that the EO industry and whatever your trade association and your professional association is should approach the UNEP and the ICCM and present to them the outputs of this project and what else you can do in this regard. And I think it should actually be an essential and integral part of any tailings dam safety management program. So thanks for the opportunity to comment, Jeff.
Thanks for your comments. Brendan, do you wish to respond?
Yeah, I'm not sure that we're in disagreement because I think we're on the same page. I think the safety regarding tailings dams is paramount. Maybe Sean picked me up wrong, but I don't know. But I think we're definitely see it from the same side in that regard, that it's a hugely important issue. And if I diminish the priority of it in terms of mining companies, I didn't mean to, because as a person in the mining industry, I see it as hugely important. I see it as a huge an issue now that is being managed better now than it was. And part of this 3,500 tailings dams is really a legacy issue, and it's something that mining companies who own the tailings dams have a huge responsibility for. But unfortunately, mining companies don't only own that. A lot of the governments now have been left with these legacy disasters, and they have to manage them. And yeah, I think a global response to that would be a great idea. And I would hope that the mining industry would play its part in that. So.
For public companies, I mean, I think there's a lot more interest from shareholders now in these questions. It's still got a long way to go, but the whole question of ESG is becoming quite prominent. Dimitrios Blioris, you wanted to make a comment as well.
Yes, thank you, Joe. Hi, I'm Dimitrios Blioris. I'm a project advisor for EASME, an agency of the Commission, and I'm dealing with projects on raw materials. And by the way, I'm an Earth observation expert. So I'm listening very happily what you're saying. And as a comment, in order, what I see from my projects that I'm coordinating and managing is that the lack of knowledge of Earth observation in the mining educational cycle. So what I would like to see is when somebody studies mining engineer, to have a course on Earth observation inside in the university. So by the time he's becoming a mining professional, he should already be aware of all the options and possibilities Earth observation can offer in his everyday work. One point is this. And secondly, we're having a number of projects that are dealing with exploration, as well as the other cycles of the mining circle, that they're publicly available from the Horizon 2020 portal, that I would invite you to come in contact with those projects and coordinators. And I can even give you some links and names to discuss bilateral what kind of services and what kind of collaborations you might be able to establish. And that's all. Thank you.
Okay, thank you. I mean, certainly, if you want to, send anything around, we're happy to act on that behalf. And in that respect, also, Natasa has posted into the chat a comment about the fire project that we're currently running, where we're looking at a number of different sectors and trying to understand what are the barriers to the uptake and what needs to be done, what R&D needs to be done ultimately to improve the uptake, but not just R&D. And the sorts of points you're making, Demetrius, I think are perfectly fine as well. Okay, I think we've pretty well come to the end of the discussion. We've run out of questions. If anybody's got a question that I've missed in the chat and really wants to put it, then please jump in. We even authorize you to open your microphone for a moment. Otherwise, we'll close down this formal part. So I'll just reiterate a few things posted in the chat for information, including around our industry survey. A particular thanks to our guests today. I think it's been a good discussion. I think it's a really important topic. I was instrumental in the oil and gas activity at the time, and I think the extension into other sectors, and the raw material sector is certainly one of high importance to try to break down some of these barriers and raise awareness of what EO technology can bring, as we've heard. The next EOcafe will be in 2 weeks' time. Each takes place on the Thursday at 4 o'clock. There's a 2-weekly cycle. Next time we're going to be looking at the Green Deal. We'll look at the probably update to the EU space program and the way the Green Deal is going ahead. But primarily want to try to. Everyone's heard a lot about the Green Deal. We know there's a lot of buzz, but what does it actually mean, and what can it mean for the EO sector? So that's the topic that we want to address next time around. Please join us then in the normal way. And okay, reminder for the survey for the EO service companies there. Please do fill in the survey. The link's not there, but if anyone needs it, is it not going to appear, Natasha, if you click again? Apparently not. No. Okay.
We put it already in the chat, so it's
in
there.
The chat. That's true. Yeah, thank you. So at that point, I'll close the cafe as usual. We keep the cafe itself open, so anyone who wants to just stay around and chat in an even more informal way, then please feel free to do so. And hope to see you next time. Thanks everyone, and stay safe.
Goodbye.